We have a generator of pulses, a variable duration, less from 1 second, and then we have a counter. But we don't want to count pulses shorter than 0.1 second. This goal can be achieved by connecting between pulse generator and the counter RC integrator. Our counter has a threshold of 8 volts. What it means that a signal below 8 is not counted, signal above 8 is counted. Originally, our pulse has practically infinitely short rise time and fall time. If we pass such pulse through RC integrator, then we obtain as the output signal exponential rise, which means that the rise time is much slower, designated by a time constant RC. C is given 1 microfarad, and our task is to size R such that this exponential curve rises to 8 volt after 0.1 second. Obviously, these tasks can be easily solved algebraically. This is output of our integrator, exponential rise, and we want at this time instant this value of exponential rise, then we may find the boundary value of R, which is 62.13. Obviously, this value that we will assign to this resistance should be slightly larger, let's say 33 kilo ohm, and then the exponential will rise after this time of 0.1 second, will rise to a voltage slightly lower than 8, and then such pulse will be not counted. For this resistance of 63 ohm, the time constant of the circuit is 63 milliseconds, and then a gap, a minimum gap between pulses, such that steady state condition 0 voltage is reached before the next pulse. The gap time should be greater than, equal than this value, let's say 0.35. After this time, the capacitor, which is fully charged to 10 volt, is fully discharged. We may verify these results by means of PSpice. So this is schematics. This is our pulse, variable resistance, the resistance that, let's say, from 1K to 100K with 100 points per decade, and we perform the parametric analysis of this circuit to find a resistance such that 8 volt is reached after this time. So we have variable, it is a parametric analysis, performance analysis. We have the variable resistance on horizontal axis, vertical axis voltage at this time instant. Then we are looking for the level of 8. This is our level. At this level, value of resistance is as calculated before. That way we have confirmed that our manual calculations are correct. We may check. This is our capacitor voltage, and we may check that after 0.1 second, which is here, this level is slightly less than 8, which means this pulse has a duration equal or less 0.1 second is not counted. This is the combination of pulses. This pulse has a duration of 1 second. Then we have the minimum gap of 0.35, and then we have a pulse of duration of 0.1 second. Well, okay, as we can see, this initial condition decays to 0 after this gap, and then this output voltage rises to voltage which is slightly below this threshold, which means that this pulse is not counted. And now another combination of pulse generator and the counter. This time we don't want to count pulses if gap is less or equal 0.1 second. Once again, we may use this RC integrator. Originally the fall time is practically 0 nanoseconds. We can make this time larger by passing these pulses through RC integrator. So obviously our output is exponential decay. At this initial condition decays to 0, and we want at this instant of time, which is 0.1 second, we want this voltage to be 0.8, the magnitude of pulse, and very easily we may calculate that the boundary value is 48 kilo ohm, and value slightly larger has to be selected, such that always this level is not reached. I mean, voltage is greater than 8 if duration of pulse, if duration of gap is equal or less 0.1 seconds. We may verify, we may check whether steady state condition is reached for such pulse of 4 seconds. Obviously, yes, steady state condition is reached after 225 seconds. We may verify these results by means of PSpice. So this is parametric analysis, parameter sweep, and we have resistance on horizontal axis. On the vertical axis we have voltage at this instant of time. We have a capacitor which is discharged, and we may, tracing this trace, we may search for the level of 8, and for this level we will find the value of resistance, which is exactly the same as the one that we have calculated before. This is our response. The capacitor is discharged through this resistance, capacitor of initial condition equal 10, and after this time 0.1 second, this value is greater than 8, which means that for this gap next pulse will be not counted. Okay, this is a combination of pulses, so duration of this gap is exactly 0.1 second. For this gap is not detected, and not detected as this voltage, output voltage, drops to voltage which is greater than the threshold. Here is a gap 2 times greater, 0.2 seconds, and for this gap obviously this voltage drops below the threshold, and the next pulse is counted. So actually for these pulses that we have on the screen, we have only counted 2 pulses, 1 and the second. Okay, that way we have completed this problem, use of RC integrator.